Completing a problem based on the convolution theorem, let's see one more problem. And here I've changed the function, and let's see how to get the value of this by using the convolution theorem. So here we have to find out the inverse Laplace transform of this given function by using the convolution theorem. So guys, before proceeding to convolution theorem or before proceeding to solution, let's see what is the convolution theorem and what are the steps that we are going to follow it. So I'm sure that you have seen my previous videos, and there I've already covered these steps, but for this numerical I'll again revise the steps. So here there are steps in front of you. So according to the convolution theorem, here you can see that inverse Laplace transform phi1 of s into phi2 of s is given by integral 0 to t f1 of u into f2 of t minus u du. It means guys, the given question can be divided into two parts, which is phi1 of s into phi2 of s. So the middle sign must be multiplication. Now my question to all of you is how to divide this function in two parts such a way one function will become phi1 of s and other function will become phi2 of s. So should I take this s square plus s with s square plus 1, or should I take this with the second function? Now guys, if you observe carefully, then from the numerator I can take s common. So by taking s common, we will get s plus 1 in the bracket, and then we'll divide the given function into two parts, that is phi1 of s and phi2 of s. So here I'll say, so therefore so it is equal to Laplace inverse of here s into s plus 1. I have taken s common, and here we will get, so it means the denominator is as it is, and now we will divide this function into two parts. So I'll say here the phi1 of s, that is the first function, is this one, that is s plus 1 upon s square plus 2s plus 2, and we will call phi2 of s as s upon s square plus 1. Now why I've taken this type of combination? The reason is, for this phi2 of s, now inverse Laplace transform is possible, because guys, if you will see the steps, then in step number 2 we have to find out the inverse Laplace transform of phi1 of s and phi2 of s. So first step we have done, that is we have taken phi1 of s and phi2 of s separately, and now we have to find out inverse Laplace transform of each function separately. And guys, for that reason I've taken s with s square plus 1, and I've taken this s plus 1 with s square plus 2s plus 2, so that here I can apply the first shifting theorem. So guys, now let's start. So if I try to find out inverse Laplace transform of, let's say, phi1 of s, what I have to do is, since I have s plus 1 in the numerator, I'll bring s plus 1 in the denominator as well, so that becomes the function of s plus 1. So here I'll say inverse Laplace transform of phi1 of s So it is inverse Laplace transform of this. So s plus 1 as it is. Here I'll write that this as s square plus 2s plus 1 plus 1. So I divided that 2 into 2 parts, that is 1 and 1. So s square plus 2s plus 1 becomes the formula of s plus 1 the whole square, and 1 remains, which I'll keep as it is. And guys, you can see here that this has become the function of s plus 1, and the inverse Laplace transform of this by using the shifting theorem is e to the power minus t into Laplace inverse of function of s. So just replace this s plus 1 with s. So s plus 1 will become s upon this will become s. So s square plus 1. Now guys, this is e to the power minus t, and inverse Laplace transform of this by using the standard properties, it is cos of t. So here I got the inverse Laplace transform of first function. Now I call that function as f1 of t, because it is given that Find inverse Laplace transform of first function and call it as f1 of t, and for second call it as f2 of t. So now I'll call this as f1 of t. Now let's find out the inverse Laplace transform of second function and call it as f2 of t. So guys, it is equal to again cos of t, and I'll call this as f2 of t. Now I got f1 of t and f2 of t. Now from f1 of t, I'm gonna find out f1 of u. So for f1 of u, I've replaced this t with u, and then from f2 of t, I'm gonna find out f2 of t minus u, and for that I'll replace this t in f2 of t by t minus u. So therefore f1 of u equal to, now guys, this is the value of f1 of t, just replace t with u. So e to the power minus u into cos of u, and f2 of t minus u is cos of t minus u. So guys, we got the two values, that is f1 of u and f2 of t minus u. And now let's apply the last step, and which is nothing but the convolution theorem. So by convolution theorem, the inverse Laplace transform of this is integral 0 to t f1 of u into f2 of t minus u du. So let's put the values together. So here I'll say by convolution theorem, it is Laplace inverse of phi 1 of s into phi 2 of s. So multiplication of that will be the original function. So here if I multiply these two functions, I'll get this back. So I'll write down those terms. So s square plus s upon now on the right hand side, by convolution theorem, we'll get integral 0 to t f1 of u, which is e to the power minus u into cos u, and f2 of t minus u, which is cos of t minus u, and I'm going to integrate it with respect to u. So guys, let's find out the integration, and let's substitute the limits, that is 0 to t, and we'll get the inverse Laplace transform of this given function. So how to find out the integration of this given function? So in the function, we can see that there is one exponential term and two trigonometric terms. So to get the answer, first of all, I'm gonna use the defactorization formula for this cos u into cos of t minus u. So I'll write down the formula for you all guys. So we have 2 times cos of a into cos of b, and it is given by cos of a plus b plus cos of a minus b. So let's use this formula. So here I will call this inverse Laplace transform as, let's say, f of t. So f of t is equal to integral 0 to t. Next, e to the power minus u as it is. And now for this, I'll be using the formula. So cos a, so a is u and b is t minus u. But guys, in the formula we also have 2, and this 2 is missing in integration. So what we'll do is, since I'm going to write down this as my answer, I'll shift this 2 to the right hand side. So that will become 1 upon 2 in the bracket cos of a plus b. So it's u plus t minus u plus cos of u, that is a, minus b. So if I subtract this, I'll get negative t plus u into du. So now let's simplify this term. So first of all, I'll take this half outside. So 1 upon 2 outside, integral 0 to t e to the power minus u as it is. Now here guys, u and minus u will be cancelled, so we will be getting cos of t only. Next here, u plus u, that is 2u, so here we'll get positive cos of 2u minus t into du. Now we'll multiply these two terms with e to the power minus u, so here we will get half integral 0 to t and guys, now let's find out the integration of each term separately. So let's find out integration of first term. So here I'm integrating with respect to u. So cos t becomes constant. So I'm going to take that outside and we are going to find out the integration of e to the power minus u. So guys, here for f of t, half outside, inside the curly bracket, cos t is outside since it's constant, and integral of e to the power minus u here is negative e to the power minus u, and that is from 0 to t. Next, here if you see the second function, then we have e to the power minus u into cos of 2u minus t, and guys here I'm gonna use the property of integration. So I'll show you here. So let's say if I want to find out integration of e to the power ax into cos of bx into dx, then it is given by e to the power ax upon a square plus b square, a cos bx plus b sin bx. So guys, let's use this formula. So here this ax is minus u, so I can say that value of a is minus 1. So here I have written the formula in terms of x, but you have the question in terms of u. So what you have to do is you just have to compare a and b with the formula or with the given question and just replace all x by u. So here a is negative 1, b is 2, and all x will be replaced by u. So here we'll get answer as plus in bracket e to the power minus u upon, now here we have a square plus b square. So a is negative 1, so that will be negative 1 square, which is 1, plus b square, that is 2 square, which is 4. So 1 plus 4 is 5. So here I'll write down it is 5. In the bracket we'll get a, which is minus 1. So minus 1 into cos bx, so it is 2u minus t. So minus of cos of 2u minus t. Next we have plus b, so value of b is 2, so 2 into sine of 2u minus t, so plus 2 into sine of 2u minus t. And guys, it is from 0 to t. Now let's evaluate the integral by putting the upper and lower limit. So here half as it is in bracket cos of t. Now I'll take this negative sign outside, so we will just get e to the power minus u in the bracket. Let's put upper limit, that is t, so that will become e to the power minus t. Middle sign minus, let's put lower limit 0, so e to the power 0 is 1. Next plus, now here in this function I'm gonna put the value of upper limit as t, so this will become e to the power minus t upon 5. Here 2t minus t, that is t, so that will become negative cos t. Here 2t minus t is t, so that will become plus 2 sin t. So guys, this is what the value of upper limit. Next, so here I'll put the bracket. Next minus, and then we'll put the lower limit. So lower limit is 0, so e to the power 0 is 1 upon 5. Here we'll get cos 0, so 0 minus t is minus t, so cos of minus t is cos t, so that will become negative cos of t. Next here if I put 0 over here, I'll get plus 2 sine of minus t, because 0 minus t is minus t. So sine of minus theta is minus sine theta, so minus sign will come outside, so minus 2 sine t. Now let's simplify it. So half as it is. This negative sign I'll take it inside, so 1 will become positive, this will become negative. So cos of t as it is 1 minus e to the power minus t. Here this is from these two terms we'll take few terms common, or first of all we'll take this negative sign inside and then we'll take the terms common. So here I'll get plus e to the power t upon 5 into negative cos of t. Then I'll multiply this term with 2 sine t, so that is plus 2 e to the power minus t upon 5 sine t. Next, minus and minus will become plus, so plus cos of t upon 5, and minus plus, so plus 2 by 5 sine t. Now guys, let's take similar terms together and that will be our answer. So f of t is equal to, so half as it is. Now this first term as it is, which is cos of t into 1 minus e to the power minus t. Now guys, here from these two terms I can take cos t upon 5 common, so I'll get e to the power t and 1 in the bracket. So here I'll say plus cos of t upon 5 common. Now since I have taken cos of t upon 5 common, from here we'll get negative e to the power t, and from here I'll get positive 1. So 1 minus e to the power t. Similarly, from these two terms I'll take 2 upon 5 and sine t common. So plus 2 by 5 sine t. Let's see what we get in bracket. So from here we will get 1, from here we will get e to the power minus t. So 1 plus e to the power minus t. And guys, let me tell you that this is the function of t. So here we got the value of this given function, or here we got the inverse Laplace transform of this given function by using the convolution theorem. Thank you.